Welcome to the Jordan Harbinger Show. If you watch or listen to this show, you're probably a big believer in science and put a lot of trust into it. I know I do. But what happens when we lose some of the transparency that is the cornerstone of the scientific process? Today, we're going to discuss why hype in science can be bad for society, bad for medicine, and those of us that rely on it, which is probably all of us. We'll also learn how and why incentives in science are often skewed and lead to bad science and even outright fraud. Enjoy this episode here with Stuart Ritchie. The book starts with a professor, from the look of it, kind of trying to prove that we're all psychic when it comes to porn. Is that... Did I understand that correctly? Okay.
Basically, that is what that paper, and that was published in a mainstream psychology journal.
So what happens there? First of all, are we psychic when it comes to porn? And if not, how did we get that far? How did that happen? How did that get published?
It is a kind of absurd thing, and that's, the absurdity is part of the story. This was a paper published by Daryl Bem, who's at Cornell University, who is like a top-rated social psychologist, well-known, well-respected. Published this paper that it was he got Cornell undergraduates to come in to sit in a computer cubicle, and actually people in the US only say cubicle. No, it's us in the UK. In the UK we say cubicle for offices and toilets.
We only use it for offices.
Yeah.
Although I strongly recommend that we start using it for toilets because coincidentally, there's a lot of overlap in those two activities.
I think so. Anyway, so they're looking at a computer screen and they're told there's two pictures of curtains on the screen. Behind one, there is a picture. Behind one, there's nothing. So you just have to click the one there's a picture behind. And they say, well, I don't know what one. And they just say, well, just whatever one you feel. And if the experiment claimed to show that if you put a picture of just something really boring like a tree or a chair or something behind one of the curtains, people get it 50-50, right? Just what you would expect. They get the picture, they click the one that there's a picture behind 50% of the time, around about that. But if you put porn behind one of the curtains, so he claimed in this experiment, then they get it like slightly above chance. So they get it like 51.3% of the time or 53.1% of the time, like just slightly above 50%. So, and that was a statistically significant difference, and it apparently showed that the undergraduates could sense that there was porn in the future going to be shown to them. And there was like an opposite way around where they put like a violent, unpleasant picture behind one of them, and they tended to avoid that one, like just by chance. And they couldn't possibly have known that that was the one that was going to come up, except by psychic intuition.
Okay, except for since we know that that's not real, or so far has yet to be proven. What happened here?
Well, yeah, I mean, people would be like breaking casinos, I think, if they could like really sense the future in this way.
Right.
But there are several things that occurred here. I mean, this was a paper which was used all the standard ways that psychologists, academic psychologists use to analyze their experiments. Right? It was a standard experimental setup. They used standard statistical analyses. They used published it in a mainstream psychology journal and so on. And yet it got these completely absurd results. And so what a lot of people concluded from this was that there must be some kind of problem with the standard way that psychologists analyze their data and do their research, which, is part of what this book is about. But what also happened, what also was kind of revealing about this, was that we ran the same experiment again, me and a couple of my colleagues, back when I was at University of Edinburgh in Scotland. We ran the same experiment again, and we found no such results. Like, we found no psychic results in our replication study.
Right,
and we sent the replication, exactly. And we sent our replication study off to the same journal that had published the original, and they said, Sorry, we're not interested in publishing replications. So they were interested in publishing the like super flashy psychic results,
fake psychic results, fake psychic porn results. Yes,
and not the one that said, you know what, actually, probably people don't have a psychic ability to detect the future, and so like. I'm not claiming that this is a fraudulent result, right? This is not this is not a case where someone has just made up the data, but it's a case where the standard methods that we use in our studies have led us to results that we kind of all know are not true, right? We kind of know that.
Okay, so
that can't be real.
the guy who ran this, right? And I assume it was a guy, because let's be honest, who does a psychic porn study?
It was indeed a guy.
How he also knows, and his team is like, this is bullcrap, but we're going to get it published, right? It's kind of like that, right? They're not like, wow, we've discovered this groundbreaking psychic pornography effect.
I actually think that in the the world of parapsychology, which is what he was, the research that he was doing, I think there are true believers. I think people believe that this stuff is real. I think people believe that we have like a tiny tendency. It's not like you can go to the medium and get them to read your tea leaves or whatever it is, but it's that we have this kind of tiny little thing that evolution has built into us to kind of search for erotic stimuli in the future and avoid violent stimuli in the future, and also like just to generally sense stuff that's coming up in the future. I mean, the part of the experiment that we specifically replicated was just about word lists. Like, we didn't do the exciting porn part, but
sure you didn't.
Well, I wouldn't even know where to look for porn.
Oh yeah, of course.
Yeah, and so
I got a guy.
And so, yeah, I think these are, I think we can safely assume that he believes that this is true. There is a kind of tradition in psychology of parapsychology research, but it's been described as like the jester in the court of science, because it's like a really absurd thing, which looks really ridiculous and is kind of totally like, it doesn't fit with physics. Like, in physics, there's causes and then effects, not the other way around. It doesn't really fit with physics, and yet. It kind of illustrates that there's something maybe a bit funny with the way we do science. And so if you dig into the statistics of the paper, there are lots of reasons where he might have been able to find what looked like a real result, but actually there wasn't. And you can kind of, and this is again what I go into in the book when I'm talking about like the bias that scientists have. You can convince yourself that you found something real when actually you haven't, and it's just noise. It's just statistical fluctuations in your data that you've collected. And if you're really if you really believe something and you really want something to happen, if you really want something to come out of your data, which a lot of scientists do, they want to find the next cure, they want to find the next big exciting result, they want to find the next thing that'll change the world, then you can really you can run the statistics in such a way that it comes out with really whatever you're looking for.
Right, that makes sense. If you're a psychologist who studies the paranormal, and there's not a whole lot to work with because we found that there just isn't really that so far, at least no proof of that. And you're looking for that, and you're looking for that. And it just so happens that if you find something, you'll be world famous overnight and at the top of that field forever. Right. There's a strong incentive to just maybe slide something to the left when maybe it shouldn't have been slid to the left.
Absolutely.
Thereby getting some imaginary results.
Yeah, exactly. And it's not even just a matter of like doing the statistics. It's a matter of like the way people write up their papers. Even if they haven't really found much in their paper, they can write the paper as if this is like the most exciting result ever. And the nice thing about this story, and the reason that this story is so good, I had the experience of like the failed replication and trying to get that published, and I think that illustrates a lot about the way science works, the kind of journals, and we can talk about that.
Yeah.
But I think the paper itself illustrates so much about how, if we just let people just carry on with the standard way they're doing science, they will find like on their face patently absurd results, like the porn sensing, the remote sensing of porn. And so I think this is like it's for good reason that this was one of the first studies that kicked off what's been described as like the replication crisis in psychology.
Right. And we'll talk about that, right? Because look. Why the hell was that published? That's what everyone's thinking. Is how is it that got into a journal? It's not one of those. It just seems like. Well, let me back up. Do most scientific studies just get published?
Well, most scientific studies that get published, and this is the vast majority of them, have positive results, right? And that implies that not all scientific studies are getting published. So let me just kind of elaborate there, which is that. When you're running a scientific study, you're looking for you're interested in testing a hypothesis usually, and then obviously once you've tested that with statistics, you're sending that off to a journal, you're getting that published. That's your kind of what you really want. It gets peer reviewed. The peer reviewers check that you haven't screwed anything up in the analysis. They check that you've written up in a fair way and whatever, and then it gets published. But there are lots of like ways that can go wrong along the way. Well, yourself.
Let me pause this here though, because if I'm looking to test a hypothesis, shouldn't like half or more than half of my tests of hypotheses just not yield anything? Like, I guess I was wrong. I mean, shouldn't that happen more than being right?
I think we could debate about like how many hypotheses we'd expect to go wrong. Like scientists can make an educated guess. A hypothesis is usually an educated guess, so you might not expect it to be just 50-50. You might expect it to be slightly higher than that because they're like testing the next thing that comes from their theory and so on.
Right, it's
But
not
you
just
wouldn't
like whole
expect it.
cloth. Like I'm not just pulling something and flipping a coin and being like, new
I
hypothesis.
think it will do this correlated with this, or
Sure.
this experiment will work on this. Like, yeah, people are like following a line of research, so you'd expect it to be maybe higher than 50%. But you wouldn't expect it to be like over 90%, which is what
Right.
it is in some fields. In psychology and psychiatry, it's been shown that over 90% of studies find like positive evidence for the hypothesis that they're testing. And that implies either that the guy at Cornell was right and psychologists are actually psychic, or it implies that something has gone really wrong with the way that we publish science. And as we're saying, like, there are all these biases that push us towards only seeing these positive results. So like this isn't how things have actually happened. The literature, the scientific literature, which is supposed to be a really nice reflection, like a clear, accurate reflection of what scientists have been doing, does not accurately reflect what scientists have been doing. In fact, it just shows this kind of rose-tinted view where all the results are positive because, first of all, scientists don't publish the studies that they do that don't support the
you
hypothesis.
tried that, right? And they were like, nah.
Right. Yeah, exactly, precisely. So that's a clear example of where they said, hey, we'll publish the really exciting initial result, the one that shows that, you know, that psychic powers are real, but we're not interested in showing the one that they don't. You know, that's too boring.
Is this why we see all this crap like in CNBC and it's like eating red peppers can cut cancer? It's like scientists : eating red peppers can cut cancer risk by half. And you're like, what? Oh, probably not though. Right.
I think, you know, there's a bit in the book where I specifically take like nutrition research to task because I think it's exactly that. I think you have these huge data sets where people collect data on like people's dietary habits and they fill in every food they've eaten for the last 2 weeks or what they can remember, you know, they ate for the last 2 weeks. And then their health outcomes and all sorts of different, you know, mental health, physical health, whatever. And you if you dig around in that data for long enough, you'll find something. And you can find red peppers and cancer if you want. You can find eating milk and eating eggs and drinking milk and heart disease. You can find drinking red wine and heart disease, all sorts of stuff. And you can publish it. And that's why the literature on nutrition is so confusing. You know, a huge amount of the findings are likely to be just statistical noise rather than like real signal, which is what we really want. And people want to know. Like, this is a real failure of science because people want to know what they should and shouldn't eat, right? That's a big, clearly, you can see from the amount of books on this that get sold and the amount of interest in this that there is. People want to know, and scientists should, at this point, have been able to provide reliable evidence on that. But we're still really not at the point where we can reliably tell people that.
Well, you must be popular among your fellow scientists for blowing up all their studies and results and making it harder for people to claim street cred by writing their bullcrappy, you know, science articles.
It's this movement, this kind of you know, since 2011 or so, when that psychic paper got published, the kind of movement of the people talking about the replication crisis have certainly caused a lot of upset. Like, people are very upset about that. People are saying like, yeah, but I've made my whole career on, you know, publishing positive results basically and doing this.
And that's why you're part of the problem.
And why, exactly. But, you know, it must also be said that lots of scientists are like, oh God, yeah, right enough, we have a serious problem here. And there have been some positive kind of, you know, steps in the right direction in terms of changing the way we publish stuff.
So social science is something you spoke about a lot in the book. So priming was one of these. Can you sort of briefly explain priming? Is that... I'm going to do a bad job, so just go ahead and do it.
Well, it was a particular, like, almost like a fad in social psychology for maybe, you know, a decade or more, where there were loads of these experiments about unconscious cues in the environment and how they can affect our behavior and our feelings, our beliefs. I mean, here's what my favorite example of this, which I think actually might only be in a footnote in the book because it has never actually been directly replicated, but I would put money on how that replication would go if someone else came along and tried to do the study. But this is one where they got people to come into a room, students again, and they were doing a creativity test. And so it's like, how many uses can you come up with for a brick? So that's, I mean, psychology is not a very high level of like assessing people's creativity if that's what they can do, but that's probably the best we can do, like in the lab for a creativity test. They had the people either sitting, like they had a big cardboard box in the middle of the room, and they had people either sitting in the cardboard box while they were doing this test, this creativity test, or sitting outside the box when they were doing the creativity test. And what they found was that the people who were sitting outside the box and thus thinking outside the box had had higher scores on the creativity test than those who were sitting in the box. And so the idea here was, like, this sounds completely absurd to me, and I'm sure it does to most people. But the idea was that priming the concept, or priming that idiom of thinking outside the box, had actually translated directly to people's creativity and made them, and given them a boost in how creative they were.
Mm-hmm.
And there's a whole host of studies that are like this. And this wasn't just a tiny effect. This was like a huge boost to their creativity because they were sitting outside the box versus inside the box. And so, like, that type of research, that general type of research where, things in the world influence your behavior even though you're completely unconscious of them. Holding a cup full of warm coffee makes you feel warmer to your friends compared to holding a cup of cold water, because the concept warmth is activated in your mind, and so you feel warmer in a metaphorical sense to your friends when you fill in the questionnaire about, like, how much do you like your friends and family. All that kind of stuff has not done well when people have tried to replicate it. It's not done well when people have looked into the stats, but it was a big thing in psychology, and it has made its way into loads of really popular books, including by really reliable and respected people like Daniel Kahneman. There's loads of stuff in Thinking Fast and Slow, his like ultra popular and really good, overall really good book. I'm not criticizing the book. I think it's a great book, but he says in that book there are these studies on priming. Unconscious influences can have big effects on our behavior, and these are published in scientific journals, and this is a direct quote. He says, you have no choice but to believe that these are true about your behavior.
So that's scary, right? Because this is a brilliant scientist who wrote I guess, could you call that a seminal work? Because everyone reads it and everyone talks about it. I don't know.
He's the only person to have won a Nobel Prize, technically in economics, but he's a psychologist, so like he shared the Nobel Prize for that. So he's like as big as it gets in psychology.
Here's this guy saying, well, even if I think that sounds fantastical, it was published and it's settled science. Therefore, it's settled science or whatever. Yeah. So it almost sounds like he's talking to himself, like, geez, that doesn't sound right. But you know what? Who am I to say that this person who did all this research is wrong? And it's like, you're a Nobel Prize winning, multi-million copy best-selling author, but we can't expect him to go, that doesn't sound right to me. Let me just do a brief 3 to 5 year study that's double-blinded and funded by some organization just to make sure this isn't bullcrap. But he has to believe it.
He totally would get the funding to do such a study.
Sure.
And to be fair to him, he has, after several years of like these results being criticized and failing to replicate when other people tried to do them and to do the replication studies, he has come back and said, look, I was wrong about this. I shouldn't have been so certain. But if he, and by the way, his specialist subject is how we're irrational and how we make incorrect conclusions about stuff and how we're kind of drawn into thinking in irrational ways. If even he can make the mistake, like, what hope is there for anyone else? What hope is there for the rest of us when we're like assessing science and understanding science? So all these priming studies have become I think they've become slightly less popular now in social psychology, and people are kind of moving on to kind of different stuff after they've realized that it was kind of fun. I guess it was kind of fun to come up with all these ideas, like warmth, the concept of warmth. Yeah, what would that do? Oh, let's do that. There was one where it was like being higher up on an escalator made you feel more high and mighty, so you would like rate yourself more arrogantly compared to your friends and stuff. Like there was stuff like that. And I think that study was actually like fraudulent. That was made up. But like there was a whole spate of these studies, and it might be kind of fun to come up with, but actually quite scientifically flimsy, when you look into them.
One of the biggest ones and this happened on our show, and I had to sort of eat a little bit of crow on this, is I had a guest on named Amy Cuddy, and she had that power posing thing. I know you're well aware of that, but for people that don't know, this was the idea that you could... It's so Tony Robbins when you think about it. Like you stand up and you raise your arms in the air and you can either scream or stand up in this very dominant body language. And it's like, look at what we found. And she did a TED Talk and it got like, I don't know, 80 million views or 28 million or whatever, umpteen million views. Yeah. Okay.
It's the second most watched TED Talk of all time, I think.
Right. And it turned out to just be not real.
Well, it was based on one study of 42 people, right? And it turned out that study, the lead author of that study, who was not Amy Cuddy, I mean, she was like one of the 3, I think, authors on the study. But the lead author of the study, who's Dana Carney, who's at Berkeley, I think, she came out and said, I don't believe this anymore. If you look back at the way we did the statistics in the original study, we kind of like dropped the odd participant out here and there and did it kind of inconsistently. We kind of we ran the statistics in such a way that we kind of picked the ones that picked the results that were positive and kind of just kind of hushed up the ones that were negative. And again, it's not like accusing anyone of fraud. It's bias, right? It's bias towards finding exciting results, just like in the psychic study that we talked about, and in the nutritional studies. Only in rare cases is this like deliberate fraud, but it's like the whole way that the incentives are set up. And think about the incentive of, you will have a New York Times best-selling book. You'll be able to go and have the second most watched TED Talk of all time. Millions of people will watch your, it must be said, like really well put together, emotionally involving whatever TED Talk, if you publish this study and if you do the statistics in a certain way. So you can see how these like incentives are pushing people towards like getting the result rather than pushing them towards, finding true things about the world, finding true facts about the world. And that power posing study, have been various attempts to replicate it. And I know Amy Cuddy is still quite pro it being true, the power posing effect, and there's huge debate over that. My view, although the debate tends to be Amy Cuddy versus basically everybody else who's kind of saying, look, this is not reliable, and especially the claims in the study about your testosterone rising when you do the power pose, and the hormonal stuff really hasn't held up at all. The subjective feeling of power possibly is true, but it might also be in the experiment, the comparison is between people like slumped over versus people doing the power pose, and it might be more a negative effect of slumping rather than a positive effect of doing the power pose. So it's like the whole thing might be a bad interpretation of the data in the first place. So it kind of has crumbled.
Yeah, I mean, I understand. I don't know her well, so I can't be like, oh, it's all a bunch of crap so she can get speaking gigs. Like, I can't say that. But also, it would be hard for me. I'll speak for myself. If I had a TED Talk and it had however many million views and I became famous for that and I was getting speaking gigs all over the world about that, and someone said, hey, there's a problem with our data, I probably wouldn't be like, we got to tell everyone about this. I'd probably be like, that's really inconvenient for me economically, professionally. I'm not sure I really want to dive into that rabbit hole right now because I am about to retire in 5 years off this.
Well, this is why I suggest in the book that scientists should consider like more widely what counts as a conflict of interest, right? So at the moment, scientists, if they're getting paid by a pharmaceutical company, or if they've consulted for a pharmaceutical company, or and they're doing a drug trial, say, it's like totally required. You must say that in the paper, you must write in the conflict of interest section, I have received money from AstraZeneca or Pfizer or whatever the company is. But they don't have to say, I have a conflict of interest in that I published a really popular book and did a really popular TED Talk on this topic. And it would be really, as you say, it would be really inconvenient for me if the results went a different way, or went one particular way. So I just want to declare that as a conflict of interest. Like, no one does that, and in fact, you would like most scientists would think that was really weird if you said that. But I think people should reconsider. I mean, nutritional research is another one. It's been suggested that nutritional researchers who are on a particular diet themselves, who are like following one particular diet, and then they do a study on that diet, they should declare that in the paper, because they have a clear interest in proving themselves right. Like, I haven't been wasting the last 5 years of my life.
Yeah, right. Yeah, turns out all this stuff I've been doing that definitely has sunk cost fallacy mixed into it, turns out I was right the whole time.
Right, exactly.
I just want everyone to know. Yeah.
Yeah.
That's a problem for, I think, medicine too, right? Because if doctors have to rely on what is low-quality science or low-quality evidence because the alternative is no science or no evidence, then bad science, which is what we're talking about, makes this problem a lot worse, right?
Precisely. You've got to make a decision as a doctor. You've got to say to a patient, like, we will treat you with this now, or or I think this is the best thing to do. And if you look through the scientific literature, often the only data is low quality stuff from small studies, studies that might be statistically dodgy in the way that we've described. You might be missing, because of this publication bias idea where people only publish the positive results. You might be missing studies that were genuinely done, but that just have never been published, that just haven't made it into the journals because the journals weren't interested because they're negative results. And so, scientists have really failed doctors in this case, and, by extension, they've failed patients because they haven't provided an actual proper, reliable, accurate summary of what has been done scientifically on a lot of these drugs and treatments. And so yeah, that's why you often see this phenomenon that's been described as a medical reversal, where like a much bigger, higher quality study comes along and totally flips the understanding, totally flips the evidence around on some medical treatment. I mentioned a few in the book, like peanut allergy, for instance. It was for a long time, people were encouraged to keep their kids away from peanuts, when they're babies, because that would be helpful in terms of stopping them from developing a peanut allergy. Then a really big, I think 2015 or so, like a really big, high quality, long term randomized controlled trial came along that actually properly tested this, and it turned out it was the absolute opposite. The best evidence was that if you expose young kids to eating peanuts, they will be less likely to develop an allergy in later life. And there's loads of treatments that have had that. There's a book called Ending Medical Reversal by Vinay Prasad and Adam Sifu, which is well worth reading. I reference it in the book, about medical treatments that have just that have gone completely opposite because the evidence was never really there in the first place, and yet that was all doctors had to use. So as I say, scientists have really failed doctors in this respect.
Yeah, that's a huge problem because that affects all of us. It's not just like us science nerds that are like, oh, it turns out this thing is wrong. It's like, no, when you go to the doctor, and we see this problem now with people taking drugs that aren't really adequately studied because they're afraid of getting coronavirus or something like that. I mean, I'm literally getting emails from people that are like, trust me, the gargling with bleach works. I haven't gotten it yet. And I'm like, oh my God, you're literally ingesting poison. And people will say, I get the occasional nasty letter from a crazy person that will say something like, you're doing, and I feel bad in a way because these people are genuinely worried that I'm spreading disinformation. And I'm like, no, you don't realize that what you saw in the Plandemic movie was fake and fraudulent. And we'll get into fraud in a second. That's a different thing. But can you tell, are there any sort of basic guidelines where if we're reading a science book or we're making a change in our life, say a diet, or based on some scientific finding we've read about on CNBC or whatever we picked on earlier, how do we evaluate how strong the evidence is? How do we say, is this bullcrap or not?
It's really tricky because different studies will have like some of them will, for instance, be really new, and so it's really hard to tell if that's been properly evaluated. I have a little kind of checklist in the book in the appendix of what you should do with any study. So you can look at like how big the sample was. You can look at generally whether you feel like the authors might have a bias in one direction or another, whether there's a reason for them to be saying what they're saying, whether it's political, or we've just talked about other conflicts of interest. One of the useful thing I think is to look for news stories that talk to other scientists that weren't involved. So the whole thing about the psychic study was that me and my colleagues, as independent researchers, came along and tried to replicate this, right? So what do independent researchers think? It's all very well getting quotes from the scientists that did the study in the first place, but what do other people think? Because of course, science is all about that. It's all about, reviewing each other's work and this kind of social process of building up knowledge. So I think you can look for if any independent scientists have commented on it, and there are specific ways to do that. In news stories, there are also places like in the UK, we have the Science Media Centre, where they actually, whenever any finding that comes out that looks like it might be kind of controversial, they ask a whole bunch of other scientists what they think, and they write a little review of the paper, and they say, well, this one had a kind of tiny sample, or this doesn't make sense, or they didn't control for this, or whatever it is, and so you can get independent views. Another thing is just actually, like, if you've got the URL of the paper, just put it into Twitter and see what people are saying about it. Like scientists often spend a lot of their time like critiquing other people's work on social media.
On Reddit, Reddit will shred science. Even good science is not safe.
Amazing threads on Reddit on some scientific papers. PubPeer is another website where if there's anything like dodgy about a paper in terms of fraud or anything like untoward, other scientists can anonymously comment on the paper there, so they can say, and we'll go on to discuss it. We can say that data doesn't look quite right. There's something a bit funny about this. Can anyone dig into this in a little bit more detail? Of course, when you look at social media and look at Reddit and Twitter and so on, you will get the less educated comments and the less high quality comments too. So you have to bear that in mind. But I think that's one of my main pieces of advice is just look at, especially if you can't access the paper itself, just look at what other people are saying about it and see if there's a general consensus of this looks really good and really solid, or as has been the case for many of the coronavirus papers. There's a massive flurry of all this research appearing on coronavirus, but there's a lot of people discussing it. And so you get these threads saying, here's why this paper is wrong, 1, 2, 3, 4, 5. And so I think just checking what other people are saying rather than just relying on the results of that one paper and the way it's written is probably a good idea.
I always look on Reddit. There's actually a subreddit called Is It Bullshit? And then there's also Rational Skeptic, Debunk This. And you can post things in there and say, hey, this paper says this.
Right.
But what's up here? And you'll find like the top 20 posters in there will absolutely annihilate pretty much anything you dump in there.
Yeah. No, I think that's extremely useful. I mean, that's basically what you're asking there is for post-publication peer review, right? So peer review tends to be done pre-publication, but we know it's inadequate. We know that all the papers that I discuss in the book that are fraudulent, that are biased, that are have mistakes in them, that are hyped up, have almost all anyway, all the ones I'm talking about in the book, and there's dozens and dozens of them, have all passed peer review. They've all got through the system that's supposed to be like the ultimate quality check. And so we need to be much more open to, as you're talking about there, just asking other people, other experts, or people who just know the field to dig into a paper and say, look, what are the pros and cons of this, even though it's been through the peer review process. And I think we make a huge mistake by saying, this is peer reviewed, therefore, it's reliable and trustworthy in some way. That's just shown to be totally inadequate.
Let's get into fraud, because this is where you think that's scary, that you can just start a diet that doesn't work or do something else and it's peer reviewed and it turns out to be BS. That can happen by mistake. That can happen via bias. And that's what we see in a lot of the social psychology that we've had on the show. I mean, I've been doing this show for almost 14 years. So there are people that come on and then years later people are like, remember this person? Yeah, lost their license, or this study turned out to just be completely made up. And I'm like, oh, oops. And like the power posing thing. Like, I don't think if Amy Cuddy were here, I wouldn't say, you're a charlatan. How dare you?
No,
I'd be like,
no.
I'd ask her what she thinks, and I'm sure that when she explains it, it sounds perfectly rational, especially to her, about why the results are still legit, Yeah. But fraud is much more terrifying and often lethal. The study that you talk about in the book, or the example you give in the book, there's this doctor that did he invent trachea replacement, and then that just turned out to be a bad idea and he just kills a bunch of people by this? Take us through this. This was nightmare fuel.
Yeah. I start the fraud chapter with this because it's such an amazing story. So Paolo Macchiarini is his name. He was a surgeon at the Karolinska Institute, and the Karolinska Institute is like the top university in Sweden, or one of the top universities in Sweden, and it's where you win the Nobel Prize for medicine and physiology. Like, it's where they call you up and say, Stockholm calling, you've won a Nobel Prize. Like, it's a seriously respected, august institution. Like, it's a really great place with a great medical school, the Karolinska Medical School. And he was recruited there, and he, as you say, he was replacing people's windpipes, tracheas, with it had been tried a lot. Like, there's a really difficult problem in science.
You said trachea? Have I been saying trachea or trachea wrong my whole life by saying trachea?
When I recorded the audiobook, the audiobook producer said to me, I said trachea, and the audiobook producer said to me, isn't it trachea? And I said, no, I'm pretty certain it's trachea. And then we looked it up, and it's trachea.
Wow, I'm pretty sure that pretty much all of North America says this wrong. I've never heard anyone say that.
It's possible that it's a UK-US thing, actually, yeah.
Wow.
But my UK producer, and for the UK, when we're recording this in the audiobook, said trachea. Shall we just say windpipe? I mean, I'm happy to.
No, I'm happy for you to say it weird the rest of the show. I'm cool with that. I think, look, I'm going to
say windpipe.
You already have this bizarre, sort of amazing, unusual accent that a lot of people are going to write to me and say, I sounded interesting, just didn't understand any of it. I like it, so go for it.
It's just a standard Scottish accent that I've got. So he
you want me to get you back on track? Okay.
Yeah. He came up with this idea of taking stem cells from someone who'd had like an injury
Okay.
Or maybe cancer, or for some reason their windpipe was blocked or damaged. And he had the idea of taking stem cells from them and then taking this artificial windpipe and kind of seeding it with the stem cells for the transplant recipient, so that it kind of it wouldn't be rejected. That's the big thing in transplants, is that, you transplant a skin graft to someone, it gets rejected because it doesn't work with their immune system.
Right, the immune system attacks the new tissue and tries to kill it.
Precisely.
Right,
precisely.
okay.
And that's like the ultimate problem in any kind of transplantation. And it looked like in this case that he had solved that, or he was at least, one of the first people to have successful operations where you replaced a big section of someone's windpipe with this special stem cell seeded electrospun. It was made of artificial materials, and it wasn't like from a donor. It was completely artificial, but it had the stem cells in. And he published papers in some of the world's top medical journals. The Lancet, for instance, is one of the most respected medical journals in the world, and he published a couple of papers there. Several other journals accepted his papers, saying, "We've made a successful operation on a patient on their windpipe. We've made this massive breakthrough." It turned out that even though it was being reported as a major success in the papers that he published, and again, this is peer-reviewed publications in the scientific literature, it turned out that he was just lying about that. He had fabricated the details of the patients, and in fact, several of them had died. One of them had died before the paper even went to press. Like, they had died, and they didn't stop to say, maybe we shouldn't publish this paper that says it was a really successful operation. He had a kind of second base of operations in Russia where he was doing more of these transplants, which were failing really badly. There's a horrible story that I kind of recount in the book of one of the patients talking and saying, like, I have like pus coming out of my neck constantly. There's a big hole in my neck, and it's just failed terribly. I want to. There was a little kid that he did this operation on in the US that died very, very rapidly after it happened, and there was never any evidence that this worked, because he fabricated it all. And he also fabricated data on like rats that he had that were kind of a preliminary part of
this is just malignant narcissism, right? He just wanted a scientific cred, and he's like, if you have to die for me to get some pats on the back, so be it.
Right. And the fascinating thing about it was that he was a con man in other areas of his life too. There's an amazing story.
Surprise, right?
In Vanity Fair. Right, exactly. So there was an amazing story in Vanity Fair where he was like having this affair with I think like an NBC news producer who, and he said, oh, by the way, we're going to get married. The Pope is going to officiate our wedding because by the way, I'm the personal doctor to the Pope.
First red flag right there. But
he said, like, I am the Pope's personal doctor. And also the Obamas are coming to our wedding, and Elton John's going to be, doing the music at our wedding, and, all this kind of stuff. And it turned out he was married to someone else. He had kids the whole time. Vanity Fair contacted the Vatican, and they said, we've never heard of a doctor with this name. Like, the Pope clearly has not got a doctor who has the name Macchiarini. He had just been making all this up. So he was a total like a con man, just a
sociopathic con man. Yeah.
But isn't it amazing that a con man like that had managed to con like one of the world's top medical institutions and the world's top medical journals and all the peer reviewers that reviewed his work? There were like people when he was first employed by this institution. There were people, some of whom are on the Nobel Prize committee, who were lobbying the university. We got to get this guy employed. We got to bring him here. He's great. He's a really amazing surgeon. He's going to change the world. And it looked like he was changing the world. Like, it looked like he was making, if you just read the papers and took those scientific papers at their word, he was absolutely revolutionary. And
it's like some Epstein stuff, right? Where you're just like, everyone's vouching and you're just like, what happened? And is some of this just because normal people don't automatically assume that somebody making an extraordinary claim is a psychopath that murders children? Because I don't know if I would jump to that either, right?
That's one of the best explanations for it, I think, is that scientists basically don't want to believe that other scientists are just making stuff up.
Yeah.
And in some cases that's because they themselves have co-authored a paper with that scientist. Like, that's one of the saddest things about fraud is that, you can have like 5 authors on a paper, say, and one of them is fraudulent and has made up the data. And none of the other ones have any idea about it, but it taints all their careers because this one person has committed fraud. It happens all the time. It's a really, really sad thing that happens to people's, careers, is that they have this thing, and then the investigations that go on for years, and it really ruins your life for a long time because someone has committed fraud. But yeah, I think scientists just trust each other. The whole system is based on trust. When you do a peer review of a paper, you're very rarely sent the raw data that goes along with that paper. In this case, it's not like the peer reviewers were sent the medical records of the patients, like the raw medical records as they were written about the patients. They weren't like involved. They didn't visit the patients and check how they were doing or anything like that. They took the claims that were written down in the papers at face value, and it turned out that they were fraudulent.
Oh, so you're already getting, even if you're checking someone's work, you're already getting a version that has been manipulated, has a shellacking over it, has been possibly cherry picked.
Yeah.
It's already been pre-selected. That doesn't even, I mean, I guess it makes sense because otherwise you'd have to do the whole study again, kind of, but it also means that you just can't catch, that explains why some of this fraud just seems so lazy, right?
Right, because they assume that no one is really going to go in and really check, because it's extremely rare that anyone actually sends out the raw data. I think in the last few years, it's been increasing a little bit more that people have put their data online and said, like, I've noticed that when I'm reviewing papers, you often now see a link to the data are available at this place, and you can go and download that and just do some checks and just make sure it looks okay and just double check that what they're reporting in the paper is not like completely divorced from what's in the data. You can argue about how to analyze the data. I mean, obviously that's a big part of science, is saying, well, no, I think you should use this model. That's all fine. That's all like totally legit. But it's whether the data actually exists in the first place, or whether when you look at those numbers, when you see those raw numbers, which often people do for the first time in fraud cases, and they say, oh God, these raw numbers are just impossible. Like there's no way that this could have happened in reality. This is not what a data set looks like.
One of the tells you wrote about in the book was that numbers are noisy. So when the data is really clean, like all the numbers are even, or they're all within like X of each other, it just doesn't make any sense, because real numbers are just so, it's like, you say noisy, it's just like dirty data. It's like, oh, there's one person that has a value that's way over there. Well, okay, they did the thing wrong. This other person didn't fill out the questionnaire. This other person lied. And that's all in a real raw data set where you just have people that are way off base. But if everybody sort of fits neatly into the area that you needed to reach the conclusion, you end up with all these different fallacies, one of which I think is called the Texas sharpshooter fallacy, where you just take all the data that shows what you kind of wanted, and then you draw a circle around that and get rid of everything else. Or there's like cherry picking and things like that goes on, where you just pick the sample size or you pick the samples of people that support what you want, and everybody else just gets tossed out. And you're like, look, it works.
It's really difficult actually to draw a line from, between fraud on the one hand, where people are like just, in some extreme cases, like opening up an Excel spreadsheet and typing in the numbers that they want, right? And then, there's a blurry line. Where does that become just like analytic decisions and what I call in the book p hacking, because you're trying to get your p value, which is this really important statistic. You're trying to get it below a certain level, and that's where the cherry picking and all that you just described comes in. So like the line between fraud and doing stuff with the statistics that you kind of know is going to give you the result that you want, or you kind of know it's going to push your data in the right direction, is really hard to draw. Like it's hard to draw that. But in some of the cases, in some of the really extreme cases that I talk about in the chapter in the book on fraud, like, this is obviously made up. This is like you look at the data, and one of the worst fraudsters, the guy who has had more papers retracted than any other human being in history.
What an accolade, right? Like, I am the most discredited scientist that's still breathing.
It's like the anti-Nobel Prize. It's like the worst possible thing you can get in science.
Yeah.
I think he's had 182 papers retracted. So he's a Japanese immunologist called Yoshitaka Fuji. He there was an analysis done of his trials. These were all trials of like new. Sorry, not immunologist. He was an anesthesiologist. They're all trials of new like anesthesiology treatments, and they And they, the group, the experimental group and the control group, had like basically identical variation around their means. So they were almost like it was just a made up bit of data where he like added 1 to every score or something, to make it look different. So it was like really obvious when you look at it. These trials never actually happened. These trials could not have been real. No real trial would have been so like regimented and perfect looking, like pristine looking like that. And yet this guy had, as I say, 180. I think they looked at his publication record. 182 trials were fake, and I think 3 of his publications were maybe based on actual real stuff that he'd done, which is amazing. But the first flags of this happened about a decade before he got like fully busted for fraud. Like someone published a paper, and it said something like, the title of the paper was something like, the statistics reported by Fuji are really nice. And what they meant was that they didn't mean that as a compliment. They meant that as like, they look too good to be true. They are far too perfect. And then, that was kind of discussed at the time. And then about a decade went by where he was still publishing fake studies before someone else came along and said, like, I have now found definitive evidence that this guy is making up the studies, that these can't possibly be true. So it can often, and that was the case, by the way, with Paolo Macchiarini, the windpipe surgeon, because he was basically, there was an investigation done. These allegations came out, like whistleblowers from his. There were other doctors who were looking after the same patients, and they said, "Well, these patients are doing terribly, and this just doesn't fit with what he's written in these scientific papers that are being spread to the world and whatever." And they went to the university and said, like, we think something really bad is happening here. They got someone independent to do an investigation, and then the university said, actually, do you know what? We've done our own investigation. This independent investigation, which by the way said that there was scientific fraud happening here, we've completely discredited that, and we totally believe that this guy is truthful. The journal itself, the Lancet, one of the world's top medical journals, ran a crowing editorial that said, Paolo Macchiarini is not guilty of misconduct. This is, and then just a few weeks later, when all the stuff about the Pope and all that came out, and also there was this documentary where they actually went and met some of the patients and saw the terrible condition they were in. After that came out, they had to all humiliatingly climb down and say, okay, we were wrong. Actually, this guy has been fraudulent all along. So in this case, you had like big medical institutions covering up, and like they were on his side. They were on the side of like a psychopathic fraudster that was leading to the deaths of his patients, which is crazy when you think about it.
There are examples in the book where people were like photoshopping the images of their data set, right? Like they'll take one picture and they're like, look, and then they do a mirror image of the same thing, and they're like, here's another sample.
Yeah.
It's crazy to me, some of the stuff you listed in here.
Yeah, it's like in microscope pictures of cells or whatever. The peer reviewers are obviously just not looking at every single one and paying enough attention. And so, as you say, people can duplicate. They can like Photoshop things, touch things up, flip things around, recolor things to make it look more like their result that they want is true. And it happens all the time. It's really, really common in biology research. There are researchers out there who specialize in like trying to detect this, and they're like trying to make AI algorithms that go through papers and say, wait a minute, this picture looks identical to this picture, so there's something wrong here. And it's the same principle as the data thing. Like, this looks too good, this looks too perfect. There's no way that in reality this cell would look absolutely identical in every way to this cell. There's no way that would be the case. So someone must have touched this up.
Imagine what's going to happen when we have AI that can go over all the past scientific data sets and go like, hey, there's a problem here. Right. We're going to end up being like, so it turns out that 30% of all the stuff we thought was human knowledge, it was just complete bullcrap made up by somebody who wanted to get tenure at a university.
Genuinely chilling thought that the only reason that won't happen for a lot of like data sets is because scientists have hidden their data sets and they've got them in a drawer. They've got them in a drawer somewhere. Yeah, exactly. Yeah.
Freaking infuriating. So if top journals have fraud, then less prestigious journals probably, would you say they have even more fraud, most likely?
It's hard to know. It's like this question of like, all the frauds I talk about in the book are frauds who've been caught, right? So they've screwed up in some way. They've like put, they've made their data look too pristine. Or sometimes they've admitted it or whatever. The top journals, and also another reason that the people who publish papers in the fraudsters that publish papers in the very top journals might get caught more often is because of the attention that draws. Like, these are it seems like a really dumb strategy to publish your fraudulent data in a really top journal because
Yeah.
everyone's looking at it. The world is looking at it. There's news stories about it. Huge breakthrough has happened in whatever field. Someone's going to look at it, and eventually, if enough people look at it, someone will say, "Just a second, that doesn't make sense," and then start digging into your fraud. So maybe, as you suggested, maybe the best thing to do is to kind of hide your paper, your fraudulent paper, in a journal that's less prestigious, that's less well read, that's less well known. And undoubtedly that happens. That must happen a great deal. It's just that the scrutiny isn't there, so you just don't pick up on it. So there's this weird problem of like selection bias where it looks like we've got all these, fraud might even be worse in the top journals, but it's probably just not getting noticed as much in the less prestigious ones.
I looked at retraction data, and it looks like 40% of papers that are retracted, these are rounded numbers, of course. Speaking of perfect data, 40% or so, it's because of a mistake, which happens and is forgivable and is something that just happens in
It's
in
actually
science.
good. It's actually good if you've made a mistake and you say, "Hands up, I made a mistake. Please retract my paper." That's actually really respectable. Like all scientists should. There shouldn't be like a stigma against if you put something out there that's objectively wrong. It's really I have huge respect for scientists that say, "Oh my God, I made a mistake. I'm so sorry. Please retract this, and we'll do better next time." That's great.
And then 20% looks like outright fraud, which was a much higher number than I really wanted to see, honestly. That was a bit much.
Yeah, it's really worrying. The fraud, as well as like plagiarism and other kind of problems, like actual bad behavior on the part of scientists. That's a majority of the retractions, and we want to get to the point where there's not a big stigma, and retractions are cool. You can retract things when you make mistakes. That's fine. And only a minority of those retractions are for like the real bad characters, the people who are actually like making up the data.
What scares me is something like 4 in 10,000 studies are retracted, which to me doesn't mean that there's not that much bad science. It just means that most people are not getting caught doing this.
Yeah, absolutely. And there are undoubtedly fraudsters who are really clever about the way they fabricate their data, who are really who make data sets that look convincing and look normal and look not too pristine. They look like a real data set that was generated by like actual data in the real world rather than a human brain. And so they're never going to get caught, and they may even be more dangerous to our scientific knowledge than the ones who have been caught, and we'll never know.
From your book, I saw that the biggest offenders of fraud are repeat offenders that make up a large amount of retractions. You mentioned that Japanese anesthesiologist that has, I don't know, how many was it? Like a
something
lot?
like 182 retractions, something like that. Ridiculous.
That's
number.
a hell of a lot. I was going to say 18, but then I was like, am I off by an order of magnitude?
Yeah.
How are guys like this still able to publish and work? How are scientists like this able to get funding, work in a lab, and put a paper out there? How is it not just, more of this nonsense from this guy? Like, I don't even want to open this email, delete.
Well, that's often what happens after the fraud allegation is made. But the problem is that the fraud allegations get made, and then sometimes years pass before any actual decisions are made by the universities. And you can understand why that is, because
it's
universities,
embarrassing.
Right, they're embarrassed. They're on the side of their academics, usually against like some random person from the internet who's emailing in, and also, innocent until proven guilty. They do actually want to check. Like it does happen sometimes that people point out a fraudulent study and it turns out, or what they think is a fraudulent study, and it turns out that it wasn't fraudulent. They've just misunderstood. That does happen. So you can see why universities. I wouldn't want my university to, if someone accuses me of scientific misconduct, to just say you're fired. I want them to do a proper investigation.
I think once you're on your 117th fraudulently retracted paper, they might be like, we've given you a few strikes here, buddy.
The problem is that it often is all retrospective. So one is discovered, one fraudulent paper is discovered, and then people look through all the old publications and they go, oh my God, this is really, really, really bad. It's like plagiarism. You find this with not just scientists, but like other authors who plagiarize, like bloggers who plagiarize stuff, journalists who plagiarize stuff. If you find one instance of plagiarism, you look back through the person's work and you'll probably find more, because this is like a personality trait. It's like something people can't help but do. It's just the way they are. And it's the case with fraudsters too. You find the first instance or the first discovery of fraud in someone's publication record, and then you look back at all the stuff they've been publishing, and often they're quite prolific. You'll often find a lot more as well, which is all I'm doing there really is saying that like personality traits exist. Like some people are like a bit like antisocial in their personalities, and that feeds into the way they do science too.
I mean, that totally makes sense. If you take 1,000 scientists, you're going to find, I would assume, a roughly equal percentage of people who are delusional narcissists, just like you would if you took a big group of lawyers or anybody.
Absolutely,
possibly more in the lawyer group, but that's just I'm saying this as an attorney. I maybe just ran across a few more due to exposure. We'll see. That could be my own bias. But
I don't want to make any assumptions there.
Who's committing this fraud, though? I do see that there's more in India and China, and I thought that was interesting. And why? Why do we think there's more fraud happening in India and China as opposed to? I mean, there's plenty happening in the West as well. I just want to be clear, but why is more happening from that area of the world?
It's hard to know. I mean, in the case of China, so I have a quote from the doctor and writer Stephen Novella, and he suggests that the totalitarian regime in China is not really conducive to doing science properly. Like living under a totalitarian regime is not like the best atmosphere for free exchange of ideas and, criticism of people's ideas and so on. And so, he particularly points to this study of acupuncture trials where 100% of those trials showed that acupuncture worked, right? Even if acupuncture really does work, you're going to find the odd trial that shows it doesn't because of, as we've talked about, numbers are noisy, statistics are messy. Sometimes you're going to undershoot the real effect of a treatment. So it's really unlikely that 100% of trials that have ever been done in China on acupuncture did actually show a positive result. So something is going on there. And what he suggests is that, acupuncture is part of traditional Chinese medicine, which is favored by the Chinese Communist Party because it was kind of codified by Chairman Mao. And so this might be something that they want to support, that they particularly are, they reward scientists who come up with, support for, this kind of traditional Chinese medicine idea. And that gives a huge incentive for people to make up their data.
This reminds me in a way of all fascist and totalitarian regimes sort of find their way into science. And it reminds me of, this is obviously more sinister, but the Nazis and eugenics, where they were like, hey, look, here's this scientific basis for why we hate people that aren't quote unquote Aryan race people. Right. And the acupuncture thing is a little more benign, I would think, because it didn't result in a Holocaust or mass genocide. But it's not that different in that the messaging is, hey, we're the government and we control everything, including who pays you and if you can have a job. So you better find that this thing that was invented in China and contributes to our national identity is real and not a bunch of fake stuff that's a bunch of kind of old wives' tales and traditional garbage that we just still happen to be doing in the country.
Yeah, precisely. I mean, the other historical example that, this, as you say, it happens in, totalitarian regimes, fascist regimes. The other classic historical example is Lysenkoism in Soviet Russia, where you had Trofim Lysenko, who was like a Soviet biologist who basically didn't believe in the effects of genetics as we normally know it, and was a big fan of Lamarckian inheritance. That is, that you can acquire a trait and then you will pass that trait on to your kids if you've acquired it.
Like if I'm reaching up for something and I get taller, then my kids are tall.
Right, that sort of thing, exactly. It's like that the giraffe neck story, or like you get yourself. Really like huge muscles from like working out, weightlifting and stuff, and then that will somehow pass on to some degree to your kids. And so the standard rules of genetic inheritance were really strongly denied, and this kind of Lamarckian or Lysenkoist view of inheritance was pushed, and scientists who pushed back against that were basically purged. And this, many historians think that this contributed really substantially to the famines that struck in Soviet Russia and also in Mao's China, because they basically denied biology about how to breed crops, and so this had massive effects. So eugenics and also its kind of evil other image, like the evil of eugenics and like the evil mirror image of Lysenkoism, have killed an awful lot of people over the years, and this is because totalitarian regimes have come in and like trampled all over science and told people what to do. So it always freaks me out when I see politicians, like in of any respect. On the one hand, I see politicians of any like angle, like trampling over science or like making a really strong scientific claim that doesn't seem to be, alongside the evidence. I mean, you've seen all the stuff about hydroxychloroquine, and there's been all sorts of, claims made about COVID-related stuff. But also when you see scientists who seem to have really strong political opinions about something or other, that freaks me out a little bit as well. So I kind of, and it's naive to say that scientists shouldn't have political opinions and so on.
Sure.
But I wonder if they should declare them sometimes as well. And we've talked about declaring your interests, and I think there's a discussion to be had about whether scientists should say I am a member of the Communist Party, and this might have influenced my view. I'm a member of the Republican Party, and I'm doing this trial on hydroxychloroquine, and maybe this is going to influence my view because I kind of want to show that Donald Trump is right when he says that hydroxychloroquine is a good treatment for COVID-19. I actually think that one of the recent examples of a retraction due to COVID-19, which is again the Lancet, and also the New England Journal of Medicine, which is meant to be the top medical journal in the world, they had to retract this paper on hydroxychloroquine. They said hydroxychloroquine was bad, was dangerous. I wonder, I kind of have a suspicion that those scientists overlooked what turned out to be massive problems with their data. They may even have been made up by one of the co-authors. It's unclear, what the outcome of that is. They overlooked those massive problems because basically they wanted to get one over on Donald Trump. They wanted to say,
yeah, because I was going to say scientists are usually more liberal versus conservative. So the odds of them being I want to prove Donald Trump right. Actually, it's going to probably be the other way around, where they're you know what, we're going to embarrass this guy. I don't even want to look at this. Or I'm going to have a bias that I don't necessarily see. They're not necessarily deciding to do this, but they're I want this to be wrong.
Right. And there's evidence, from some of the other stuff I talk about in the paper, and when I talk about negligence, when scientists have made a mistake, and it's there's these algorithms that are trawling through scientific papers to find errors, in the statistics, and it turns out that errors are more likely to be in favor of the scientist's hypothesis, right?
Sure. Go figure.
It implies that if you find a result that goes against your hypothesis, you're more likely to check it. Oh, it turns out to be an error.
Mm-hmm.
Fair enough. But if you find a result that is supports your view and is really great for your hypothesis, you're oh, too good to check. I'll just move on to the next thing. So it's this bias towards finding results in a particular direction stops us from being skeptical about our own research, which is the whole point of science, right? It's being skeptical about stuff, it's being skeptical about our own research, other people's research, and it really stops this process of skepticism in its tracks.
How does fraud or just bad science and those consequences, how does that bleed out into industry and into things like drug research and medical treatment? I mean, we've seen some of this anti-vax bullcrap from fake doctor or discredited Dr. Andrew Wakefield, right, who this is now in the zeitgeist, if you will, and people are there's science that says this, and it's being hidden by the mainstream media or whatever boogeyman, people are looking for. Does this actually affect drug research and medical treatment, or is it kind of do we catch it before that happens?
Sadly, it really does affect medical research. For instance, loads of medical trials. Medical trials are required by law to be registered now. So since the early 21st century, the early part of 21st century, you have to, if you're doing a medical trial on human subjects, you have to register that. By which I mean you have to go on to clinicaltrials.gov if you're in the US, and you have to say, we're going to do a trial of hydroxychloroquine for COVID-19 patients, and this is the outcome that we're checking is COVID-19 symptoms. Say, if you then find that the drug doesn't affect COVID-19 symptoms, but does reduce people's headaches, say you manage to just happen to find that it reduces people's headaches, it's really, really common for the process of what's called outcome switching to occur, which is where you say, well, we were never really interested in COVID-19 symptoms to begin with. What we really wanted to look at was headache. And so you then write up the paper as if it was always about a headache, a new drug to test headache. And we probably, on page 55 of the paper, you can say we also looked at COVID-19 symptoms. But I'm using that as an example. I'm not sure there's a study that has actually done that, but this happens a lot. This outcome switching thing and it's just like the cherry picking stuff that we talked about before, where medical trials often run by pharmaceutical companies, but this does happen when government funded trials happen too. If you don't get the result you want, you just pretend you were looking for something else all along. And this
Texas
happens.
sharpshooter fallacy. I
Texas
explained it badly before.
No, you explained it very well, which is you basically you find a result because of the randomness of where numbers are, and this is the Texas sharpshooter who goes up to a barn and like randomly shoots all over the side of the barn, and then he goes over and finds like where there's a little cluster of bullet holes, and he draws the target around that. So you're drawing the target after you've made the shots, and that's what scientists are doing a lot of the time with this outcome switching thing, and it's really quite blatant, right? Because there's a record of what they have registered, that they've written down their original prediction, their original hypothesis, and then they're just like, let's do something different. Let's write the study up as if it was something else. And so there's been analyses of this that really show, I don't have the numbers right to hand, but like large proportions of medical trials have changed somewhere along the way, and aren't looking at the outcome that they originally planned to. And this is a recipe for finding false results, for finding false positive results, where you think you found something and there isn't actually anything there. It's just statistical noise. And this happens in industry. And as you say, this is the incentives of academia, and where they meet the incentives of industry, which is we want to find results, we want to find exciting things that we can then market.
And this is the most important part of the show here. I want to talk about bad results doesn't mean we can just decide not to believe in science anymore or choose what to believe without any evidence. Because I see this. I did a pandemic debunking video, and the YouTube comments are terrifying because it's like nobody addresses the content of the video. It's just like, you're a big pharma shill, or like, no, look at this YouTuber who's like a guy in a garage. He's got all the real evidence. And I'm like, no, I'm disagreeing with them, so I'm wrong, because now you're just going to hurl insult. Like, it's crazy, the lack of critical thinking, but people will hear something like this and go, see, science is also bad and has just as many errors as the guy who made some crap up in his living room this morning and put it on a blog.
Yeah. There's a few responses to that. I mean, the first one is that all of the stuff that I described in the book, the fraud and the bias and all that stuff, was discovered by other scientists, right? It was eventually, even though it took longer than it should, and I think there's real problems with the way that science is set up, all of that is, and by the way, that is set up to find positive results and so on. It's not a big conspiracy to keep down the population by giving them vaccines and like inserting microchips in them, as I believe one of the vaccine conspiracies is currently saying. What I mean by that is, what I mean by like perverse incentives and the way that the system is set up is that we're incentivizing scientists to find exciting research results rather than find true stuff, right? So that's the situation we're in. All of that stuff has been discovered by other scientists, has been pointed out by other scientists. The process of science has eventually worked here, even if it took a longer time than should have really been the case. The other response is that what my book is arguing for is for us all to raise our standards for what we count as scientific evidence. So at the moment, we've got this not very clear process of like peer review, and sometimes it works, sometimes it doesn't. You find a peer reviewed study and you don't really know whether it's reliable or not, when you should know. Like that should be the kind of quality seal where you're like, yeah, I can kind of trust this. But we've clearly shown that that's not the case. But what I'm asking for is for people to raise their standards, for people to be more skeptical of data, be more skeptical of results, be more skeptical of interpretations. And I think if you applied that sort of reasoning, like really serious statistical analyses, pre-registering your results before you look at them, your analyses before you look at the results, all that sort of stuff. I think if you applied that to the average claim by a vaccine denier, or the average claim by a creationist, or any of these kind of conspiracy theorists or anti-science, science denier type people, their claims would crumble apart in a second, right? They're even worse. Like, for instance, when was the last time you saw an anti-vaccinator retract a paper in one of their phony journals that they've got, or criticize another anti-vaccinator? These people are like clearly biased in one direction, and they're not applying the principles of science that I advocate in this book, which is like constant skepticism, sharing results with each other, and sharing results with the world, and so on. And I think the fact that there are people who deny science, who deny, the science that we can rely on, and vaccines, they've been studied, within an inch of their lives, and these are safe in many cases, and scientists, should be open in the cases where they've been found not to be safe, and so on. But things like the MMR, which is the Andrew Wakefield stuff that you mentioned, that really doesn't cause autism. The evidence is very strongly against that causing autism, which is what the original claim in the Wakefield paper was. If you look at that data, it's really clear. But the fact that there are people who say that MMR might cause autism or are worried about MMR means that we in science need to raise our standards even more. We need to say, look, we're nothing like what you claim. We're not hiding anything. We're being open with our research. We're being transparent. We're not doing what you're claiming we're doing, which is like making a kind of tacit agreement not to discuss the flaws. In fact, I had an email from a prominent chemistry professor from one of the University of California system universities just the other day, who said, you're doing damage to science by writing this book because
I could see why they think that.
Right.
Yeah.
People are gonna read your book or read your op-eds that you've written or whatever and say, well, I deny science. But what he's and basically the implication of his email was, and he said, I agree with you about the problems. I agree with you about the actual the empirical stuff that you talk about. So what he's claiming there, what he's saying is that scientists should have all these discussions in the ivory tower and not mention them to the public and not talk about anything at all. And I think that's a recipe for disaster. And I think that's actually a recipe for feeding the conspiracy theories, because it is actually making a conspiracy. It's a conspiracy of silence. It's saying, let's not let the man in the street, the hoi polloi, let's not tell them about any of these problems. Let's just work it all out ourselves, And I don't think that's adequate. I don't think that will work. I think only sunlight and transparency is the only thing that will work here. I think that's part of this whole open science thing that I advocate in the book, which is people should be able to read the papers. Anyone should be able to look at your data in pretty much all cases. And anyone should be able to see the flaws in it. So transparency is what we're after here.
Yeah, I mean, that's what's beautiful about science, right? We can crack this open, shine a light everywhere in every corner of every element of science, show the problems with it, and then get better. In other disciplines or fake disciplines or fake science, they can't and won't do that because they can't stand up to any scrutiny. So they just go to their convention and sell their self-published books, and that's the end of it.
Yeah. They're not doing the, I talk about these norms of science, like one of which is organized skepticism and there are, universalism and communality and all these kind of really important disinterestedness is one of the most important aspects of science, which is that we shouldn't come into science with an ideology or with an interest in one particular finding or another, or any kind of, political or any other kind of set of beliefs that could push us in one direction or other. Charles Darwin described it as scientists should have nothing but a heart of stone when it comes to the results. So if they do an experiment and it turns out that their theory is completely wrong, they should write up that paper and publish it in the same way that they would if a similar experiment had shown them to be right. So it's something which I used to spend a lot of time back in like 2005-06 when this felt like it was a real problem, before we had real problems and before we had like
even
real
bigger
proper
problems.
serious even bigger problems, I used to spend a lot of time reading creationist forums and creationist stuff, because I found it really fascinating that there was this, like, as good as evidence gets for any theory, the theory of evolution, and yet there were still these people denying it. And you could see that they often explicitly came in and said, if it goes against the Bible, I'm not going to believe it. And now I'm going to do I'm going to write a scientific paper about evolution. It's like, that's completely the opposite of what science should be about. And that's really what's happening in these cases. They don't have like a Bible maybe, but the anti-vaccinators are very strongly taken with, the latest Wakefield book or the latest stuff that's been written on, some of the anti-vaccine sites. And this is clearly their ideology, that their preconception that they're bringing to it. That's anti-science. That's not, and it's not just anti-science as in like the results that are published in scientific journals, but it's anti the whole scientific process and the whole way that science should work.
In closing here, how do we incentivize properly? Because to hype up some fake results or some exaggerated results, that's how a lot of scientists get funding. That's how they get speaking gigs. It's how they end up getting tenure, because they got a lot of social media followers and a lot of people want to take their classes. How do we set up the incentives properly? Because they clearly are not proper right now.
Yeah, universities are kind of aware that the way they hire scientists and the way they promote scientists and give them tenure and stuff are clearly not working. And a lot of universities now are changing, the way that they, run their tenure committees. And they say not just like, how many papers does this scientist have on their CV? We'll hire the one with more papers, because that encourages scientists to just endlessly publish low quality research. Journals are now actually changing the way they work. So it doesn't just say, we want your most exciting results, but it says we'll publish replication studies. So they can change the way they work. Funders can also, they don't want to have egg on their face when they've just poured, thousands, millions of dollars into a study that turns out not to replicate. So they can require that scientists will not just publish a paper in the most flashy journal, but will share their data with the world. They'll incentivize scientists to do stuff like be good scientific citizens and create new software that checks for errors, create new ways to be transparent and share data, create new methods that really rigorously analyze data. And I think also just talking about this stuff, so just you and I talking about this stuff now is part of how we change the incentive system, because I think we've good reason as scientists to look back at, some of these real failures, the frauds, the biases, and feel shame about them. And I think just talking about it and having this discussion about the replication crisis and the way that the incentives in science are so badly wrong, I think is half the battle, really, of moving those incentives to a better place. And that's really why I wrote this book.
Stuart Ritchie, thank you so much for coming on the show today. This is really interesting. I mean, it's a little niche, like I was a little skeptical. Oh my God, you're going to talk about the problems in science. Whatever, how am I going to make this mainstream? But you did a great job of making this palatable for an audience of geeks, but maybe not scientists.
Yeah, thank you so much. Great to be on. Thanks.
Hope you all enjoyed that. You can find a lot more just like this in the Jordan Harbinger Show podcast feed. Of course, you can find that in Apple Podcasts, Spotify, or wherever you get your podcasts. Now click here for an interview with my friend Renee DiResta on election hacking, or click here for an interview with my friend Guy Raz of How I Built This. And of course, click right down here to subscribe to the channel.